Hello class, welcome to 8.9, direct and indirect variation, or it's also known as direct and inverse variation, okay? And we're going to touch upon these things very lightly, but it's very important to know how these work. Okay, just to simply put it, direct variation means as one quantity increases, the other correspondingly increases. When one quantity decreases, the other quantity correspondingly decreases, okay? That's direct variation. They have a direct effect on each other, right? As one rises, the other rises. As one falls, the other falls. With indirect variation, it's the opposite, or inverse variation. It's the opposite. So when one increases, the other decreases, and when one decreases, the other increases. Okay? We can think of many examples in life where this can happen, okay? So let's say, what shall we say? Let's say the salary, okay, or someone, let's say Emma, earns $15 per hour, right? So if I want to measure Emma's salary, right, that salary, whatever she earns as, equals 15 times whatever she gets paid, 15 times how many hours she works, right? So 15 is kind of fixed because that's her hourly pay. What is varying is the number of hours, right? Her salary depends on the number of hours. So in other words, salary varies with the hours. Salary varies with the number of hours. We just saw that there are two kinds of variation. It can vary directly or it can vary inversely. So we have to figure out how this varies. So remember, directly means, or let me just put something up here. Direct variation means as one increases, the other also increases, or when one decreases, the other also decreases. But with inverse variation, as one increases, the other decreases, or when one decreases, the other increases. Okay, let's keep that as the background. So coming back to the salary, does the salary increase as the hours increase? Yes. Does the salary decrease as the hours decrease? Yes. So this is a case of direct variation. Okay, so it varies directly. And also the other thing to note is that this 15 remains constant, right? It's between the S and the H. Those are the variables and they are the ones that keep changing. So this 15 is called the constant of variation. Now that's cool, right? Variation means something is varying. Constant means something is still, it's not changing. So within a context of variation, you're looking for information that remains constant because that will tell you how this variation will be affected, right? So in this case, the salary is being affected by the number of hours, but each hour gets a pay of $15. So 15 is constant, and that affects the salary by multiplying it with the number of hours. So you see here, this formula here says y equals kx, where k is the constant of variation. So let's look at this problem and see if we can handle this. If y varies directly with x, okay, that itself is enough clue for you. Okay, so y varies directly with x. This in English is translated into math as y varies directly means automatically equals k, right? With x means times x. If it varies inversely, then we would have a different setup, right? So y equals kx. Just like that, we got the equation. Now we need to see what's happening. So they're saying when y is 20, right? When y is 20 and when x is 8, find the equation that relates to x and y. Okay, so let's take it step by step. Y is 20. We'll write k as it is. They didn't tell us anything about the k. X is 8. Okay, so if you look at the setup, you don't have information on k. K is your constant of variation. So they want us to find that constant. Can we find the constant? Well, yes, we can find the constant. So divide both sides by 8. Yeah. And you get k as, let me write it out here. K is 20 divided by 8 is 2.5. Okay. So, well, we found k, the constant of variation. Remember, k is not a variable. As the name says, it's a constant of variation. It is a fixed value, and we're trying to find what that fixed value is. Okay. So we did the second part. Okay. Now we need to find the equation that relates x and y. Well, we do have this equation. This is the equation that relates x and y. Y equals kx. But here we have k that we figured out, and k doesn't change. Right? K is fixed at 2.5. So now I'm able to write the relation between y and x after finding the k. And this is my response to this question. We found the equation that relates x and y with having found the constant of variation. Let's apply a real-world problem to this. When Raul runs on the treadmill at the gym, the number of calories, C, he burns, varies directly with the number of minutes, M, he uses the treadmill. He burned 315 calories when he used the treadmill for 18 minutes. That would be terrible. 18 minutes. 1, write the equation that relates C and M. 2, how many calories would he burn if he ran on the treadmill for 25 minutes? Okay. So set the scenario, okay? He's running on the treadmill. He's burning some calories over certain minutes. Okay, so that's the whole scenario. So let's now clear the clutter and see what we have. Okay, C, okay, calories varies directly with minutes M. So I'm going to just pull that information here. C varies directly with M. C is calories, M is the minutes. So let me write the equation. C is C. Varies directly means equals with a K. The directly tells you that you have to multiply the M. Multiply the M. All right, now we have some information. So it says if we burn 315 calories over 18 minutes. That's the way he works. And so C is now 315 calories. K is K. M is 18 minutes. Okay. So they want us to find the constant of variation. So let's do that. Divide by 18 on both sides. Okay. Again, it's okay if you have decimal answers. It's totally fine. Just write it the way you see it. So if you get 17.5 as our K. Okay. So the first piece of information before we go to parts 1 and 2, that first paragraph of information helps us to find K, and that's crucial. Okay, we found K. So this will help us answer question 1 immediately. Okay, okay, I will just write it out here. 1 is, write the equation that relates C and M. So C equals K times M is the relation we have. We've built it already. But we now found K to be fixed at 17.5 because K is a constant of variation. It remains constant. And right there you got your equation that relates C and M. 2, question 2 says, how many calories would he burn if he ran on the treadmill for 25 minutes? Okay, how many calories? So C equals K times, not K, we can actually use 17.5 now. Okay. This is the relation, and they're asking us to find the calories. Excuse me. Asking us to find the calories if he ran for 25 minutes. So C is still missing. 17.5 times 25 minutes. Go ahead and multiply this out using your calculator. That gives you 437.5. Okay. So we have C equals 437.5. Remember, they're asking about the number of calories, so we have to interpret this. Okay, so we'll say Rao burns 437.5 calories or would burn for 25 minutes on the treadmill. Okay, and let's box the answer there. This whole thing is the interpretation for part C, part 2. Now, for part 1, they just wanted the relation, so no story there. But for part 2, we have to write a little description of the answer. Let's move to inverse variation. Okay, as we previously saw in the beginning, if it's inverse variation, as one increases, the other decreases, right? And when one decreases, the other increases. Therefore, you can see the setup here, right? Y equals kx. Kx now becomes y equals k over x. Okay, so that y is on top and x is in the bottom. So when one increases, the other decreases. Okay, let me box that. And k again is the constant of variation. No change to that. So thinking in terms of the calories in the previous example, for inverse variation, let's say the more calories you burn, the lesser your body weight will be, right? So as one increases, the other decreases. So more calories you burn, lesser the body weight. Okay, you could translate it to body weight or body fat. It just depends on what the what your goal is. But as you can see, as one increases, the other decreases. So think of inverse as opposite, but here we are thinking of inverse as multiplicative inverse. So mathematically speaking, multiplicative inverse. Okay, so if you had x there, the inverse of x is 1 over x. Okay, so that's what we're having. That's the reason why the x, which was sitting on the top, is now in the bottom. Let's look at this example. If y varies inversely with x, and y equals 20 and x equals 8, find the equation that relates x and y. Very, very similar to the other one. Let's take the sentence, write it out. Y varies inversely with x. Let's translate this. Y is y. Varies inversely is, is equals k. With x, how does it inverse it? How does it vary? It varies inversely. So inversely with x means x must be inversed. So it becomes 1 over x. Okay. Think of the multiplicative inverse that I mentioned above here. So if it says directly, then it's directly the x there. If it says inversely, then you have to inverse the x. So x becomes 1 over x. Okay. This is what they have in the formula above as shoved together as y equals k over x. Okay? So think of it like this. But this k over x is kind of separated out for you as k times 1 over x. Okay? So I'd like to keep that relation this way. Okay, the next step says y is 20 and x equals 8. So that's 20. We have the k as it is, but x is 8. So 1 over 8. Okay? So this is 20 equals k over 8. We want to get k by itself. So go ahead and multiply by 8 on both sides. So 160 equals k. Okay. We got this relation. We got the constant of variation right here. Constant of variation. So this remains fixed at 160. Therefore, if you come back here to the relation, y equals k over x is now y equals 160 over x. And that is how it varies inversely. So when we write our answer, we don't want to write the k and the x separately, so we shove them together, top and bottom, so it becomes 160 over x. But for translating it word by word, you can see that it's easier when you try to separate it like this. Henceforth, for the next problem, we will just try to shove them together. Okay. The fuel consumption, mpg, miles per gallon, of a car varies inversely with its weight. A car that weighs 3,100 pounds gets 26 miles per gallon on the highway. Write the equation of variation, 1. What would be the fuel consumption of a car that weighs 4,030 pounds? Let's take it step by step. Fuel consumption, okay, consumption. So how many gallons is consumed, right, for the miles driven. So fuel consumption of a car varies inversely with its weight. Let's highlight that. Did they give us any variables? Well, they didn't give us any variables. So let me write this out first. Fuel consumption, it's measured in mpg, right? So varies inversely with weight of the car, right? Fuel consumption of the car varies inversely with the weight of the car. Okay, we don't have any variables given, so we're going to assign variables. Fuel consumption, so let's call it F, varies inversely equals K, always comes in, but inversely with weight, I'm going to call that W. So it varies inversely, so the W will not sit next to the K, it's going to go down below the K. Okay? So we got the relation F equals K over W. And then they gave us that extra information. You remember we said the extra information is usually to help us find the K. Okay? So when F, the fuel consumption, okay, consumption is measured in mpg. So they're saying the car that weighs 3,100 pounds gets 26 miles per gallon. So F is the miles per gallon, fuel consumption. So please position them correctly. That is 26. Don't put the first one that you see there as the first one here. Don't put the 3,100 there. Okay. So K over W is the weight. Weight is 3,100. All right, let's now solve for K. Multiply both sides by 3,100. Okay. Again, use your calculator to figure out the product here. Okay, so I get 80,600 as the K. Okay. K again is the constant of variation. So let's go back to answer part 1. 1 says F equals K over W. That's the relation we got from the question, but it says write the equation of variation. So I'm going to go further and substitute for K as 80,600 over W. Okay, that is the first part. Let's go to the second part. It says, what would be the fuel consumption of a car that weighs 4,030 pounds? We got the relation from part A, 80,600 over W. And we are given the weight of a different car, and they're asking us what will be the fuel consumption. So F is still missing. So F equals 80,600 over 4030. Let me check that number again. Yes, 4030. So divide them out, you get 20. Okay. Again, this is a word problem. Let's come back and respond to it using the units. So the fuel consumption, let's use the same language. The fuel consumption of a car that weighs 4,030 pounds is 20 mpg. Okay, and that will be our response to part 2. I hope that helps. I will see you in the next video. By the way, we finished chapter 8 with this section, and I'll see you with chapter 9.